Enders of the world unite. I'm Ray Myers. Welcome to Craft versus Cruft, and this is a very special episode. We have our honored guest, Arlo Belshee, who some of you know is just one of my greatest influences. So thank you so much for being on the show, Arlo.
Thank you for having me.
For anyone who doesn't know you, we'll put a link, catch up, but why don't you tell us a little bit about yourself and what you do?
All right. Well, I love legacy code, and I love repairing, mending, playing with legacy code. I find it is the place that all the information and knowledge is stored. People have forgotten everything about what their system used to do or why their system does what does today. The people who did figure it out have left the company, and the only place that knowledge exists is in the legacy code. And so I see myself as a bridge. I am the bridge from the past to the future that's able to bring all of our code and our great wisdom of the past to bear in the future without getting stuck in all the crap that's in that legacy code that makes it very, very difficult to work with.
So did you always see legacy code as a gateway from the past to the future and all these things? Or was that something you had to learn along the way? Like, was that your, think back. Was that always what you
Yeah.
thought?
So no, that was a shift that happened when I worked at Microsoft around 2011, 2012, somewhere in there. That was when I almost cost the company $500 million of annual recurring revenue by fixing a bug.
Oh,
Yeah.
so
So
yeah, normally we like to fix bugs on this show.
yes.
So that's kind of unusual. Tell us about that.
Yeah. Yeah. So big companies, you have big clients, and so one of the ones there was a company, a major automotive manufacturer in the U.S. Who had all of their factory control software for running the factories and assembly lines was running on top of a bunch of systems, including a database. And the database that they had selected, because it was way back in the day, was Visual Fox Pro. Visual Fox Pro had then, gone out of business and been bought up by Microsoft, and Microsoft integrated that into SQL Server. And then about a year after that happened, the automotive manufacturer lost their source code. So they could no longer modify the system, and they couldn't even recompile it. So they needed binary compatibility. Fortunately, Microsoft loves doing binary compatibility. They were happy to do that. And so they kept running the factory. And the software had not changed for 8 or 10 years, however long it had been, and was continuing to run, and they could take all the version updates. Well, they found out that they were depending on a weird edge case bug inside of Visual Fox Pro. So that weird edge case bug became part of the standard for SQL Server. I was then on the OData team, and I was standardizing how are we going to share data across everywhere and so on. And there was this weird edge case that somehow was in there. It was clearly a bug. So I went ahead and fixed it. And I got a call about a week later from the SQL Server team, and they told us, so if you do this change to the standard, we won't be able to support our own standard. And I asked why, and they told me about this manufacturer that ran about $500 million of business a year through Microsoft. And as long as all their stuff continues to work and Microsoft continues to hold to their back compat guarantee that they will not break anything that runs, then they keep doing the business. But if Microsoft decides to force upgrades, then they're going to look around, and some of that business is going elsewhere. So we ensured that bug existed. We put tests around that bug. We ensured it would never change, and we retained that business.
So this brings to mind an interesting question, which is what is a bug? Like, do you think, based on what you now think a bug to be, that it actually wasn't a bug that you fixed, that was a non-bug? Because some people would say, well, that's the documented behavior. That's the intended behavior, even if it's not documented now. At least someone intends it, so it's not a bug. Do you think it was a bug?
Well, so I have a couple of definitions of bug, and they contradict in cases like this. So one of them is anything that that would annoy, frustrate, irritate, or make sad some human were they to know it existed.
Software does that a lot.
Yeah, yeah, yeah. There are a lot of bugs in that sense. Yeah, software annoys people. The UX is terrible, or it's great, but it just gives away a whole bunch of stuff for free, and so the people who are running the business are sad, or dot dot dot. Right? There are a lot of ways that it can screw up and annoy a lot of different stakeholders. So yeah, definition of bug is very very broad. And when I'm trying to write really clean, solid code, that's the definition I use. Right. Another common definition is the difference between intention and actuality. A bug is anything that's different between what we intended and what we actually got.
Hmm.
But I don't find that definition as useful because it expects that there is one unique definition of intention, and there's not. Every different person has a different perspective, and intentions change over time and change with the market dynamics, right? And so the definition of what is and isn't a bug alters, and that's going to be true in any case, because in some sense with bug you're trying to say of all the behaviors in the system, there are behaviors I like right now and there are behaviors I don't like right now. And making a clear definition for I likes it and I don't likes it is never going to happen.
So you're embracing the subjectivity
Yeah,
in saying it will go so far as if it's confusing to someone, it counts as a bug.
yeah,
In order to
yeah,
cast it against the widest possible net. So something that you were also saying at the time in which you were casting this very wide net, because while some would say that that means that there's just such an infinity of bugs that you couldn't possibly even reckon with it, but you were also, I think your slogan was almost bug zero at that time. Like you
yep.
were trying
Bug
to
zero.
drive it to, and I don't think it ever meant literally zero, but like sort of as close to zero as you wouldn't even notice the difference. And how could that be? Can you explain to
Yeah,
people who have not seen environments that I can vouch for the existence of, but what could possibly be a near zero bug environment?
yeah. Well, so a great example from outside the software industry, and I'll come back into the software industry afterwards. But from outside the software industry, there was a story of a apocryphal, but maybe real. I'm not sure exactly. American manufacturer uh, asked for a Japanese manufacturer, supplier, for a bunch of screws, parts and screws and whatever, and they specified a, uh, an error rate. And so they said that for every 100,000 screws, we want six errors. Um, and so they sent out the order and ordered 100,000 screws. And then they got back a box with 100,000 screws and then this little baggie on top with six screws in it. And they called back and were like, what is that? I said, oh, well, those are the errors. Right? Um, because we specially created, you asked for some errors, so we specially created them for you. Right? Um, that's bug zero, right? Bug zero is being able to do everything so cleanly and doing it consistently so cleanly that you don't really have surprises. Uh, Now, in a software environment, there are teams that I know that with a definition of bug as broad as the one that I did, in a factory control sort of a space, they're able to get defect rates on the order of one bug every 18 months. And so they annoy some human once every 18 months. And still they find two-thirds of those in their initial dev testing. And so those never get there. And then, they find half of those after commit before it ever gets to production. And so when you're talking about your production rate, it's 1/6 of one per year and a half. It's zero, right?
Yeah. I don't want to tip my hand here, but I
Uh-huh.
think what a lot of people's reaction would be is it sounds like that level of quality, even if attainable, would require you to move so slowly and take such great investment that, Arlo, we could never sacrifice so much productivity that we could be achieving these astronomically low bug rates. So what are you doing?
So what I find is it actually requires that you work in a very clean fashion, in a very precise fashion. And the only way to do that level of precision is to work very, ironically, very quickly, very tiny, right? If I'm trying to, the only way that I can consistently get the output that I need, get the correctness that I need, is to be able to call my shot and then hit it, and then call my shot and then hit it, and know exactly what the thing is going to be. And software is so complex that I can't handle a lot of scope in that. Which is why if I'm working that way, when I'm working on some gnarly legacy code and I need to be in my cleanest and safest state, I'm checking in between every 90 seconds and every 3 minutes. And it's chunk, 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 chunk all day long, right? With almost no backtracking. We just, those commits will go and then they'll merge, and then the next set of commits will go and they'll merge. Sometimes I do some side explorations and find, it's not necessarily my first idea that works, but I don't end up needing to backtrack in any given idea very often. It's explore, and no, that's not one. Yeah, that's not one. Oh, that's the one. Yeah, let's go with it, right? So it's interesting to me that the thing that leads towards the greatest productivity and the thing that leads towards the greatest quality is the same thing. And that is you work in tiny, tiny steps, call your shot each time, and then refactor constantly. And you automate the heck out of everything, right? You move everything to the lowest possible risk, and that is automation. So getting some good refactoring tools, I don't write a lot of code. I have my IDE create a lot of code for me, and that's without all the AI stuff. The AI ones they don't create code as well as I need, but I can create code using the IDE very very quickly.
It sounds like you're speaking, and we hear this from a lot of different areas, that really the productivity versus quality trade-off was a perceived conflict, that really these things could have been the same goal. They could be pursued together if we're really smart about it. But why is that non-obvious to people? Why do people have then the first instinct and the tendency, organizationally, individually, whatever, of okay, we need to move fast, so we're going to do this thing that ultimately you're claiming undermines speed?
Yeah. So it's all about contexts. So there are different context situations in which the same kinds of behaviors will have very different results, right? So the results that you get are a result of the behavior and the system, right? And so a lot of us are operating in a context in which people don't know how to make provably safe changes to code that are guaranteed not to alter behavior. So if I can take code and I don't even know how it behaves, but it has some set of behaviors under the infinity of all possible inputs. Now I have a tool that allows me to mutate my design over time in a completely safe way without tests, without anything. I can go into untested code that is untestable and mutate the design until it's testable and then put in tests, right? I can write code that is trivial for some particular purpose and make sure it does that and then start mutating it out. There's a technique that I do called stick figure testing, or TDD as if you mean it, in which the rule that you hold is you're not allowed to edit code to change a single character in the product. The only way you can edit any lines of any code as text is inside of a test, as in the method that is a test. So if you want to alter behavior, the only way you do it is you write a test that does the thing. It sets some stuff up and does the execution and solves the problem. It's all in one line. It doesn't call other methods, right? And then you start
Hmm.
extracting methods and then objects and then whatever else. And you start, if you want to alter test code that's out there in production, you have to inline it into a test, alter it, get it to work with other tests, extract, refactor, right? So you end up using all of the code transformation tools a ton, and they're the only things that ever touch real code. When you're working in ways like that, those are only possible if you have the ability to instantly change the design and know that you didn't screw up the behavior. Once you have that, all sorts of things are possible. Software is soft.
In a way, we've had this idea that, and I say we, some people have had this idea that LLMs are going to be the new things that edit code. But and I've seen the way that you work, the stick figure testing. I need to see that drill. But I've seen a lot of your other stuff, and I practice very similar things now, and I find that they really do work.
Hmm.
Naming as a process and so forth. These are really effective techniques once you get the hang of them. And it is sort of like, yeah, I don't want to edit the code. If you watch my refactoring videos, it's like I'm going to avoid as much as possible directly using text editing features, and I'm going to use tree transforms or IDE
Right.
refactoring. This was kind of ahead of the time of this idea that AI is going to edit the code. Is we're going to have algorithms edit the code in ways that we can actually reason about much better. What is the limit of that? A few different ways that I could mean that. Let me first ask, can you do this on all code bases in all languages equally well?
No, because it depends on the provability of the language. Like, I mean, there are languages out there that basically consist entirely of an eval loop and everything's in the global space. And when you're in that, there's not a lot, like any change in any part of the system can have an alteration of behavior, right? There
Mm.
are languages out there, like people have written screwed up toy languages that don't have a go-to statement, they have a come from statement.
Oh
And
yeah,
so,
like
yeah,
intercal.
yeah. And so when you have something like that, that's literally explicitly in there to make it so that every individual statement has global implications, right? So, yeah. So, no. On the other hand, most modern languages are designed to be reasonably provably correct. And when they're reasonably provable, then you can do a whole lot of these sorts of things. You just need decent static analysis.
Yeah, so it's at the limit of your tools, your static analysis, and to some extent the language features can throw a wrench in that or not.
Hmm.
But yeah, I find a lot of it is like so. For instance, Java and C Sharp are kind of ahead of the game in terms of their
Yeah.
refactoring support. But a lot of that's the energy that's been put into the tools. It's not necessarily those capabilities are unique. I used to have the impression that you needed static typing in order to do automated refactoring,
Hmm.
and it does, I think, help sometimes. But the first commercial refactoring tool is for Smalltalk, as you probably know. So
Right.
apparently, the most dynamic of the dynamic languages, actually innovated this. So yeah,
Yeah.
there's we're limited by our own imagination, I guess, and our ability to code around it. So I guess you've taken to being, I guess, very interested in maintenance tooling,
Yeah.
right? That's got to not win you a lot of popularity contests, right? That's not like gonna be the life of the party.
Yeah. Yeah. I mean, we are a culture, at least in the U.S. here, that rewards makers, not menders. Right. And it's interesting. Right now, I'm in two companies, two different clients that I'm working with. One of which is a very maker, and one of which is very mender. Like I'm working
Mm,
on the one side in a brand new product, searching for product market fit, bringing things out, and all that stuff, and in the other, working with some gnarly legacy in regulated or regulated adjacent domains, and just trying to modernize things without screwing anything up, right? And yeah, on the face of it, like, and if I go out to talk to my friends at a wine bar or whatever, they're going to celebrate the work that I do in that as a maker in the startup sort of a thing, and they're not going to notice the work that I do in the other one, right? If I talk to a business person, I can talk about on the maker side, we have high hopes that this is going to, with reasonable probability because of startups, it's going to be a big bang startup, and it could make, it could make millions of revenue next year, and maybe tens and whatever. On the other side, I can talk about, yeah, we have an intention to improve performance by 30%. which we think is attainable. And if we improve performance by 30%, that's about $100 million of delta profit. Right. So, so you start talking the language of business, and we don't care about makers. Menders are the money, right? And so there's an interesting thing as you go around the organization or into different contexts, cocktail party versus the C-suite, you get very different degrees of respect for very different kinds of things.
And yeah, I mean, by the time the incentives have shifted, I guess you needed the makers to make a giant mess, such that we're really stuck in it. Yeah, now we don't know how to get that 30% and so forth. It's such I'm really I'm still at the beginning of my journey as far as like learning how to navigate these situations. I know that I though on this channel I talk, to a lot of people who they're kind of at the ground floor. They see this mess. They've read about good practices. They've been trying them. But they're just caught in this mess of tangled code and tangled incentives
Yep.
and neglect. And we try to give them some hope. But are there any particular advice for someone, kind of maybe mid-level, let's say, that's
Yep.
really trying to tackle that situation, be more successful at it?
Yeah. So I have a set of techniques that I've put together into what I call safeguarding, but it has safeguarding as a name just to put a nice bundle around it and make it easy for people to think about and consume it. But it is just a set of related techniques, right? And so, and those have to do with budgeting and with task sizing and with how you approach solving a task and with how you do root cause analysis and with how you demo and a whole bunch of different parts, right? But a lot of the essence, what it really comes down to is we're going to identify what is painful and bad, what, the bug stream or outages or whatever it is. We're going to use those as data. And not every single one, but we're going to randomly sample, and every week we'll pick one at random. And then we're going to do a little bit about it, right? And we talk about 15% solutions. We're not going to solve it. We're going to just make it 15% less sucky, right? This is the world of legacy. Good is impossible, or at least too expensive right now. So what we're going to do is make it less terrible, right? So we make it 15% less sucky, and a reasonable time box. Right? And then we keep doing that over and over. And we do a little bit on the surface and a little bit on one or two of the contributing factors, and we keep doing that over and over. And the whole point of this is that's something that's budgetable. Right? You can just allocate a small budget every week to do one random sample. The contributing factors that lead to more issues will get more investments. And the ones that lead to bigger issues will get bigger investments. And so you have just optimized the ROI for your improvement stream in terms of eliminating whatever are the things that you said were painful and bad, right? And so I don't have to do a big analysis. I don't have to think of everything up front or plan. It's just a simple steering that allows me to work with whatever size group I have influence with, right? And get us to just make things a little bit.
That's really good. Thank you. So I'd like to talk about a kind of a secret keyword that I have come to recognize your students by in the world. It's like the secret handshake they have, and you may know what I'm going to say. Is they'll be refactoring, and they have created a new method, always using the IDE shortcut to do a syntax transform, and they name that new method not anything to do with what they think the blob of code does yet, but they name it applesauce. They extract a variable or method, and they begin by naming it applesauce.
Yes.
What is applesauce?
Applesauce is obvious nonsense, right? So the whole point is that it has no meaning and it doesn't lie about that fact. If I have a variable that is of type presentation wizard and it's named presentation wizard, it is nonsense, but it's lying about that fact. It's trying to claim that it is a presentation wizard and that is an important thing. And everywhere I read it, I think presentation wizard. Oh, what's that, right? Whereas if I call it applesauce, everywhere I see applesauce, I don't know what the fuck that is. It's just applesauce, right? And that's the whole point. It's being brutally honest, right? And that's what's going to allow me to take it from being presentation wizard, to realizing, oh, this presentation wizard is holding the role of command source, or of output, or of recipe, right? The recipe that this code is following is held in the results of that wizard, right? Or whatever, right? And so then I end up with variables after they were applesauce, and we work with them. We see, oh, this is the recipe. Let's call it the recipe, and then we'll call it the other things, right? So you end up with much better names, but you always start with applesauce. It's all about being honest.
And yeah, I guess if you've already extracted an applesauce, you might have to make it a different food item or something. But to
I've seen there seems to be a split among the community between people who do applesauce 1, applesauce 2, applesauce 3, and those who do applesauce,
Yeah.
pear sauce, mango sauce, banana sauce.
Yeah, I'm team applesauce too, but that's partly because I coded into my tools, and but I've yet to be in like an actual team environment where I'm comfortable doing the full step of make it applesauce and commit and push, and then and then change the name after. That would be the full commitment to
Yep.
the methodology. But it's not about like you should have nonsensical names, right? It's always just about you should be very committed to be willing to make it just that next step better, and identifying something that needs a name is its own step. That is really what's being expressed, and I love that you're just doing such a radical thing in order to express that.
Yeah, it's in addition to identifying that just getting this out is its own step and something that needs a name. Yes, and it's about the realization that honesty is more important than being informative. Right? It's more important to be honest than to be helpful. If you, as code, could say, "I'm not helpful," then that's better for the developer than trying to be helpful. Right? And so that's what we're having it do. Is be ruthlessly honest. Be honest about what you communicate and what you aren't communicating, and then everyone can see it and can improve it.
Could you give an example, like concretely now, of something you did to begin to make headway in, one of the worst, most nightmarish legacy code bases you were ever brought on to look at?
Okay, yeah. So there are several. I could go with one that's naming, that we eliminate a lot of problems just by changing some names. And then we could talk fun about just some gnarly legacy and fun things that happen there. So naming one, there was a code base that I was working with that had a method called setFont. And one would imagine setFont, sets the font.
I mean, that would be one of the top 10 things I would start doing if I were set font.
Yeah, yeah. So what setFont actually does in this system is write things to 2 different tables in the database and make 3 different API calls to services.
I don't like that at all.
No, no. And so we had tons of integration bugs that would happen because every couple of months someone would call setFont, not realizing that it was suddenly going to lock up systems and do writes on databases and whatever. And then an integration bug shows up and then they fix it and whatever. And so at some point I got frustrated with that string of integration bugs, and so I just renamed setFont to Applesauce and checked it in. Right. And the next time someone went to try and do that, they went, "Applesauce? What does this do?" And they opened up and read it and they went, "What the hell does this do?" And that was the first time that's the first time anyone ever read setFont, right? And they started reading it, and it got a large number of people from all sorts of teams across the company who, turns out, they all used this code, but none of them understood what this code did, right?
Amazing.
And so they all read it and worked out and eventually figured out what the method should be and teased it apart to a couple of different methods and a couple of different objects and moved it around and did the right things, and then they could come up with good names. But once I renamed it to Applesauce, the integration bug stopped immediately.
We've got just a few more minutes. There's just one more question I'd like to ask.
Sure.
You've been just like me, heavily influenced by the extreme programming community. I think that methodology. I think you were an
Yep.
early adopter of. As I was like, in that next wave, I was at Carfax started in 2007, so I was,
Hmm.
midway, I guess. A lot of people would be under the impression that to adopt extreme programming, especially something like test-driven development, that you have to have started on a new code base and just like build everything from the ground up, perfectly. And so there's no way we could possibly adapt these very disciplined practices on this existing code base that was written without tests. Typically, was written, with units that are too large to meaningfully test. So I assume, based on your history, that like when you adopted XP, you weren't getting to write everything from the ground up. You were in a legacy context. How did you make that work? And did you find you had to like adapt the methodology?
Yeah, so my first one I was doing Greenfield, and so it was easy to learn there, right? But it also had a lot of things that kind of felt a little heavy, like a
Hmm.
little bit like I don't know why I need such a big engine for this. And when I got to Brownfield with my second company, it was, oh yeah, okay, I see why I need this, right?
Hmm.
And started really using it. And so Brownfield is where XP really shines. But you need to have learned a couple of techniques, and you can learn them on a Brownfield code base. Like you can start learning it there. The key is for XP to work, you need to be able to work tiny, and you need to work with a high degree of precision. Right? That's what it's all based off of. A friend of mine talks about all of Agile is based on the assumption that we're going to be wrong often. So we want to maximize our ability to change our minds when we're wrong. Right? XP says we're going to be wrong often enough without shooting ourselves in the head on the way. Right. So the first thing that we're going to do is put down all the foot guns, right? We're going to stop making the dumb mistakes, right? And once we stopped making all the dumb mistakes that we're used to regularly making, and we have lots of ways to make sure that we don't make the dumb mistakes or start making them again, then we're still going to be wrong a lot, but now we can adjust so much more quickly because we don't have all those other issues going on, right? And to get there with Brownfield, it's all about looking at what are the things that cause dumb mistakes, because developers don't want to make mistakes or bugs. Developers are well-meaning, very smart, highly trained professionals who still somehow manage to create 2 to 3 bugs per person per day. Um, and they catch about half of them themselves and half of them escape, right? And so how do developers have such a high failure rate um, if they're at all professional? And the answer is that the systems we work in are designed to cause mistakes. And developers don't make mistakes. Rather, they prevent 99% of the possible mistake opportunities that they're presented with. And then they're just presented with 300 a day, right? And then you
Hmm.
make 3 a day, right? So we just look at the system when we're bringing in XP and what are all the things that are causing people to screw up. And some of that is going to be addressed with testing and unit testing. Some of that is addressed, I'd say more of it is addressed with refactoring and automation of those sorts of tools. The automation is a process stuff that I do helps to address a bunch of the rest of that. Like there are a bunch of things that every time everyone does the manual process, they all do it differently. So the first step is we're going to start putting a checklist together, and now we'll all do it the same, right? We just eliminated a lot of foot guns, right? Then we can start automating pieces of that checklist and eliminate some more, right? And on and on. So many of the techniques that I do, so many of the techniques that the XP people have done, refactoring, was invented, co-invented right near the beginning of that. Refactoring was first and kind of led into it, right? All of those are designed to be able to work precisely and in small steps, no matter how ugly the terrain is around you. And eventually, some of it will even be in unit tests. But in Brownfield, a lot of it isn't in unit tests at first. But it's all precise, it's all rigorous, and it's all in tiny steps.
Where can people go to learn more about you and your work?
Yeah. So the best place is following me on LinkedIn. It used to be Twitter, but I don't do much over there anymore. So
Blue sky.
yeah, yeah. LinkedIn's a good place to see a lot of what I'm up to professionally. I'm working towards writing a bunch of stuff on gradualism. It's a new way of thinking about it that I've put together, where it is all the aspects of software development and leading and so on. Coming soon, 6-9 months from now probably. But follow me on LinkedIn. That'll be the place to look.
Any wistful quotes or one-liner advice you'd like to leave us with?
I'd say maximize the amount that gets done without doing it.
Very Taoist. I like it. And as Lao Tzu said in the Tao Te Ching, with patience, the most tangled cord may be undone. Arlo, thank you so much.
Thank you.